Fine. Hope
Doing good. Thank you.
everything
Thanks.
is working well.
Yes, sir. Yes, sir. I am our company some annual meeting is going on.
Okay, okay.
That's why little held up there. There is all this April, May that as usual, a team from across India has come.
Okay, okay.
Little bit upon that. Yeah.
So it will be around 1 hour, 1.5 hours presentation plus question session.
1 hour, 15 minutes. Sir.
Then
50 minutes. Like
after that question session.
Q&A. Yeah, yeah.
Okay.
First, join ಮಾಡಿರ್ತಾರ.
ಇಲ್ಲ ಸರ್.
So Nikhil is there. Nikhil has joined.
Yeah, he is there, sir.
Hello, sir.
Good afternoon,
Good
Mr. Nikhil.
afternoon.
Good afternoon, Nikhil. How are you?
All good, sir. How are you?
Fine, fine, fine. Sorry, I could not call you. I was a little busy with our annual meeting. That's
No,
why I
no,
sent a
sir. No
WhatsApp message.
worries. No worries.
I wanted to call you, but by the time I reach my home, it will be very late. I don't want to disturb your late night.
No, no, sir. It's all okay. No worries.
Okay, okay. Dinesh, we'll start exactly by 2:40.
Yeah,
Yeah, we'll wait for 5 minutes and then we'll start.
sure.
Okay, okay, no problem.
Okay, okay. Let's start.
Yes, sir. We can start, sir.
Yeah. Good afternoon, fellow countrymen. This is Sendil Kumar from IIF Chennai Chapter. On behalf of IIF Chennai Chapter, it gives me immense pleasure to welcome you all to this today's technical webinar, which is jointly organized with by Chapter and Nagpur Chapter for the first time on the topic of benefits of sandwich treatment versus core wire and value creation through SP package. I am sure it is one of the more sorted topic. I think everybody would be very keen to understand the nitty-gritties of this topic. At the outset, I would like to express my sincere thanks to IIF Nagpur chapter for collaborating with us in organizing this highly relevant and knowledge-oriented technical session for the foundry fraternity. And today's highly competitive foundry industry, continuous improvement in metallurgical quality, process consistency, and productivity and cost optimization has become essential. Advanced treatment practices, innovation process technologies play a vital role in achieving superior casting quality and operational excellence. I'm confident today's webinar will provide valuable technical insights and practical learning for all the participants. We are privileged to have with us a distinguished speaker, Mr. Swapan Kumar Biswas, a technical manager from Elkem South Asia Pvt. Limited, a well-known personality in the foundry industries who brings with them rich industry experience and the deep technical expertise in foundry process and technologies. Sir, we are warmly welcome you and sincerely thank you for accepting our invitation, sir, to share your valuable knowledge and experience this foundry community. I request all the participants actively interact with the sessions and make the best use of these technical opportunities. I once again warmly welcome you all to today's webinars and grand success. Thank you. I request Mr. Nikhil to introduce the speaker formally to the audience so that people can, even though introduction is not required, but it's still better to introduce Mr. Swapan Kumar to audience.
Thank you, sir. Good afternoon, everyone. It gives me great pleasure on behalf of the Institute of Indian Foundrymen Nagpur chapter to introduce today's distinguished speaker, Mr. Swapan Kumar Biswas. Mr. Biswas is a metallurgical engineering graduate from Jadavpur University, Kolkata, and has further strengthened his leadership and commercial expertise through the advanced program for marketing professionals from IIM Kolkata. He brings with him over 27 years of rich and diverse experience across production, quality, metallurgy, and high-end technical customer support in the foundry industry. Currently, he is working with Elkem as technical manager and is also a valued member of the Elkem Global Technical Customer Service team. His core expertise include metallurgical defect analysis, casting yield improvement, ferritic grade development without heat treatment, SSF grade development, and customer value management. Mr. Biswas has presented multiple technical papers at prestigious forums such as IFC and IFEX across various cities and has authored several technical articles published in the Indian Foundry Journal. We are indeed fortunate to have such an experienced professional and practitioner with us today. Please join with me in extending a warm welcome to Mr. Swapan Kumar Biswas. Over to you, sir.
Thank you, Nikhil and Senthil, for your introductions. Good afternoon to all. So today's in presentation, I'll go through mostly the practical experience with various customer on the value creation. So value creation in the different way. Suppose customer is facing the metallurgical challenges, rejection to eliminate with different innovative way with a high performing product. So that will give the value creation. Value creation. So in this case study, before this going to case study, there will be some technical input. Why this metallurgical defect is facing by this foundryman. So first I'll give presentation on the value creation through high performing product, and second part will be the code where there will be the advantage and disadvantage against our normal, most preferred practice is the sandwich process. So after this complete my presentation, definitely I'll try to reply question. So if it is not complete within this time frame, maybe you can send email to me, and later on I can give this reply with details information step by step. So I'll give some background that in from 1940 you can say this ductile iron start production with pig iron. But now there is a lot of changes. If you think for the ductile iron production with pig iron, everybody will think about twice. But that is the beginning. But now there is a lot of changes, thinking process, raw material availability, and expertise who are helping to this foundry personnel for improvement on the metallurgy. So in ductile iron or gray iron, always need to focus on the nucleation booster. That is the primary from the liquid metal. Whatever you are doing this casting process applying, but first you have to think when metal is ready. So what is the nucleation level? Either is gray and ductile iron both are the same. When metal inside this furnace, both are the same. But after this magnesium treatment, then that metal convert into the ductile iron. And also the low content in case of ductile and gray iron, most of the cases found if people this focus on few element, 4-5 element, but most cases they overlook on the traces element, but that is most important when you are going to produce this good quality castings. Also, when you are going for this stringent and most critical casting production, then that times narrow down this chemistry also most important and consistent process. Otherwise, it will be difficult to maintain quality heat by heat. And you have to decide which package combination is the right considering your product portfolio and configuration of these castings. So that is the raw material side, and then there are also molding and core also very important. Otherwise, it will be difficult on the correction in the one side. It will not help you to get this consistency result. Everybody knows there is a relation between the silicon and tensile. That is the linear, but when you increase the silicon level, there will be other problems. So there will be chances of chunky. So you have to decide which will be the best option. And when you are taking care of the challenges, definitely it will give the new business path, and there will be new opportunity. So challenge we should accept and work on the challenge. There will be the positive outcome. So due to the very complexity in the casting geometry and stringent requirement, predicting the shrinkage behavior in ductile iron is more crucial for the successful foundry operation. You know, this shrinkage process is the most common defect either in case of gray and ductile, and in the most cases is the common defect is the shrinkage, but identification is most important. Normally, most of the foundry, there will the few defect they studies, slag or sand related defect, and other is the gas or blowhole, but very rare cases they check the micro and try to find out what is the type of this defect, the shrinkage or gas related or nitrogen in case of gray iron. So it is very important to identify the defect, then you can take this corrective action. Otherwise, whatever action you will take, it will be maybe it will not give the outcome or result quickly. So important to study the microstructure when you are facing any defect. So and decide which type of defect, then you can take this corrective action. And optimal treatment package also very important. So it will help to get this consistency result considering these metallurgical and mechanical properties. And in this presentation, I'll explain how this metallurgical defect is eliminated by changing this combination, raw material, especially this alloy, magnesium inoculant. And for the shrinkage control, there is a lot of influence of nebulizer, especially this which type of ferrosilicon magnesium. It is normal lanthanum based ferrosilicon magnesium or the combination of lanthanum plus mish metal. And also this very important in case of inoculation, selection of inoculation. That is also very important to control the micro shrinkage for ductile iron. And in my study, there is also I explain this what is the effect of precondition. We can say it as a booster for the liquid metal for improving the quality. So that is also most important. You need to check your metal nucleation potential before taking this action. Then it will help. So in shrinkage phenomena, then you can see this slide. When metal in the liquid condition, this volume is less. But when that liquid metal converting from this liquid metal, when solidification takes place, there will be the graphite precipitation. And there is a huge expansion on the volumes. So that is the most fundamental. So whatever carbon you are using in the furnace, so that recarburizer should convert into the free carbon is called as a graphite. So when your graphite precipitation and distribution is very good, definite, it will help to control most of the metallurgical related defect. So this is when expansion is going on with this graphite, so you need this more graphite precipitation. During solidification, always everybody knows that there will be the contraction as a metal phenomena that it will contract, and when this graphite will precipitate, it will expand. So when this two parameter is almost similar, then you will get the defect-free casting. So graphite precipitation is in our hand, but during solidification metal contraction, it is the metal characteristics. So we can improve this graphite precipitation by taking this corrective action in the base metal. See, any metal when it is inside this furnace, you can take this corrective action. But after tapping from this furnace to ladle, maybe in case of gray iron for pouring ladle, or in case of ductile iron for the treatment ladle, then you don't have much time to take any corrective actions. So in that times, first target, metal should pour as quick as possible. Otherwise, there will be chances of other problem. So take correction inside this furnace before tapping. So that is always beneficial. And in ductile iron, suppose after adding ferrosilicon magnesium inside the treatment ladle, always better to tap the metal as quick as possible. Don't hold the treatment ladle for few minutes. Maybe that times melter is cleaning the metal inside the furnace. So then your magnesium will start burning from this bottom of this ladle. So always tap metal as quick as possible within 1 minute. So then it will give the better magnesium recovery. So that part need to take care during this production of ductile iron. So there is three different category on the shrinkage. One is the physical, chemical, then third is the process related. In physical related, that will be the mold or your getting system, sand metal ratio. So this part need to take care to overcome the shrinkage related issue. In case of chemical factor, then carbon equivalent is the most important, along with other traces element, especially chromium, titanium, vanadium, antimony. All these trace element need to consider. Also, another parameter is the residual magnesium. Most of the time, foundrymen think about that if residual magnesium on the higher side, then there will be no compacted graphite. That is correct. But other side, it will create this increase the shrinkage tendency, because magnesium is very strong carbide promoter. When your residual magnesium on the higher side, always tendency for the carbide formation, and you will get the less nodule count. When nodule count is on the lower side, then your shrinkage tendency will increase. So on side you are protected from, there will be no compacted graphite due to this high residual magnesium, but other side you will face the other metallurgical problem. So optimum residual magnesium is the most important for ductile iron. Normally 0.035 to 0.045 in between, that is most ideal range of residual magnesium. But it will be vary on this depending on the casting size and thickness. For bigger size, maybe slightly on the higher residual magnesium is needed. But in other automobile, mostly this range will be the most preferable range. Process related, that is, suppose metal is ready, but it is hold due to some other problem. So that means there will be the variation on your nucleation side. So that part need to consider. If there is hold, always better take corrective action before tapping the metal. And metal nucleation, that I already explained. It is any physical and metallurgical properties is very much linked with this your nucleation at the furnace. There is one case study how this shrinkage is eliminated. There is a lot of other information is there, but only outcome of our exercise. So there is this two picture in the left side, shrinkage versus this residual magnesium. When your residual magnesium will increase, so then always tendency there is a more shrinkage. And another magnesium content with nodule count. You have seen this lower residual magnesium always it will give the high nodule count. That means high nodule count is, it will help to control your metallurgical shrinkage. So in right side, there is the two picture, two different packages used. One is the left side graphite structure. It is contained is ferrosilicon magnesium, content is the mish metal, and calcium barium base contain inoculant. But extreme right side, there is lanthanum based ferrosilicon magnesium, but inoculant is the cerium based inoculant with coated special coating with oxygen and sulfur. So both cases, you can see this, there is a huge difference on the nodule count. Both are the same metal, same chemistry, but two structure is having the different graphite formation. So when your nodule count and nodulity increasing, that means you are able to eliminate micro shrinkage or micro porosity. So with the help of better ferrosilicon magnesium and cerium based inoculant, it helps to minimize or eliminate 100% elimination of shrinkage defect. So this best possible way to cure this shrinkage, you have to follow this correct carbon equivalent and carbon silicon ratio. Also, control on the residual magnesium and sulfur level. Need to check this nucleation by adding this long-lasting preconditioner, then it will help to maintain the nucleation level for the longer time. Also, in case of to overcome this microporosity, you have to select the inoculant which can provide this secondary graphite precipitation. Most of the cases, calcium barium, it gives huge number of graphite precipitation at the initial stage, and later stage will be the very less number of nodules or flakes formation. So you have to select this inoculant that can provide the graphite precipitation from starting to last stage of solidification. So that will help to control on the microporosity. When there is initial graphite precipitation on the higher side, always chances of more expansion. But at the later stage, there is no nucleation site to create the last stage graphite expansion or precipitation. So only cerium containing inoculant that gives the primary plus secondary graphite precipitation. So you have to select this inoculant along with your philosophical magnesium that helps to control the microporosity. In barium base, you will not get 100% benefit to control on the microporosity. So this is the one case study where customer was facing metallurgical challenge, especially on the shrinkage. But this casting, with the help of high performing inoculant plus magnesium combination, they are able to produce defect free casting even without riser. So that is the initial stage when our team member is visiting with various customer. Always we try to collect information on the existing condition, because at any case when you are doing some activities, you need to know the starting point. So then you can take this corrective action. Without this information or the starting point, you cannot take the decide the next course of action. So this is the initial stage provided by this customer. Whatever they are using with their existing combination, calcium barium base inoculant plus mixed metal contain ferrosilicon magnesium, all the parameter they provided, this is the structure. Then on basis of their initial information, we suggested package. So in most of the cases and case study, always we recommend to preconditioner, because this is the primary action and it helps to overcome a lot of variation. Because when your metal condition means in your health, metal health is on the better side, definitely your outcome will be better. So you have to select or decide type of preconditioner that help to improve your nucleation site, and that nucleation maintain till the solidification. There is a lot of material is available, even silicon carbide. Sometimes some people they add the pig iron at the last stage for improving nucleation. But in our case, from our R&D team, they studied and they found this zircon or aluminum containing related precondition that helps better, because it need to add into the melting furnace. That zircon or aluminum, when added in the furnace, it will react with oxygen, whatever contained inside this liquid metal, and that oxide, it will hold the oxygen level in the melt for the longer period. That oxide will not fade quickly. But in other case, maybe pig iron or silicon carbide, that will give the short period of effect. So when there is the maybe metal is the 6 ton metal and taking this around 1 hour complete the pouring. So then silicon carbide, maybe pig iron, it will not give the effect till the last pouring. So in that case, definitely you have to decide longer effect of preconditioner. So in second phase, whatever we have recommended, partly they have used and partly they decided there themselves, but still there is the problem. So then inform the customer, try with this complete combination, because your structure is not good enough, even though you have use partly suggested combination and partly you have decided yourself. So in the last stage, you can see that is a huge changes on the microstructure, especially nodule size and distribution of nodules. When we start it, so you can see this is the structure, and at the last stage when our activity is completed, you can see this is a structure. That is the change, the same metal, same chemistry, but huge improvement on the microstructure. And this casting they poured without riser, and they found complete zero shrinkage without riser. So this is the value creation. So whatever this riser quantity, this metal, that is the saving. Yes, there will be some increase on the your treatment cost, but you have to calculate what is my increase on the treatment cost and what is the benefit and yield improvement. So if you compare this both, then definitely you will find the benefit. And another things, when there is consistent result, so then you will get the each and every heat will be the similar metallurgical result. And customer, and when you will send this casting to your customer side, there will be no chances for the rejection at the customer side. So that will give the huge negative impact when this casting is failed at the customer side, OEM end. So you have to take this corrective action at your end. So definitely it will help for long term. So this case study with preconditioner, how it is helping on the machinability. This is mainly for the machinability. So this is the material you can use as a conditioner. It will help on the inoculation effect. So base metal preconditioner is the most important, because that is maintaining or holding the oxygen potential in the metal and also balancing the impurities. You need certain inclusion that is helping for the improvement on the nucleation. So this sometimes people use this little rust scrap. So that rust scrap, maybe in pig iron also there will be some rust. So this rust is the iron oxide. So when you are adding into melt furnace, so that is giving enhancing your oxygen level inside. So that also helping to improve the nucleation side. But addition should be limited, because it is the temporary effect, and when you will add more the rust scrap, then it will create other problem. There's a lot of slag formation. Maybe this during adding metal flashes will be take place. To avoid all this, always we suggest go with this good preconditioner that will help overcome all these challenges. So this is a benefit we can get from this preconditioner, that is contain aluminum and zircon. Last parameter, this improvement on the machinability and variation, reduction on the casting variation. So in this parameter, you can see this is there is one found we done this study. So that found it they are using silicon carbide around 1% in the furnace, and rejection was 1.1, very less, no doubt. And at machine shop,
Sir,
because
your
that is
screen is
also
not visible. Swapan sir, your
profit
screen is
center
not visible.
area. So they are able to machine around 635 numbers of casting. And when we suggested go with this high performing preconditioner with 0.1% instead of 1%.
Swapan sir,
Yes, sir.
am I audible?
Yeah.
Sir, your screen is not visible. I think you have to reshare again.
Like, just a minute. Oh,
Yes. Put it in
yeah.
full screen, sir. Yeah, it's okay.
Okay. So when they go for this precondition with 0.1%, so then you can see here this rejection come down to 0.32%, and number of castings they're able to machine with single tools is 935 numbers. So there is the changes around 47% improvement on the machinability. So now you can calculate this cost part is which is the beneficial, going with the silicon carbide with 1%, 1.1% rejection, or with the precondition. So when we demonstrate to the foundries, so then they switch over from their earlier package to this new package. This is also another study. See left side, you can see that the existing combination, they are getting a lot of shrinkage. Then we have recommended with high performing package. We replace from silicon carbide to aluminum and zircon containing preconditioner and lanthanum based ferrosilicon magnesium. Inoculant instead of calcium barium with lesser addition is the cerium containing inoculant. It is specially coated with sulfur and oxygen with lower addition. So then this is the right side structure. You can see this casting photo with microstructure. That is the huge changes. So after that, we have done this analysis on the what is the yield improvement. Earlier they are getting around 55%. Later on with this combination is around 70%. And they also done this cost calculation. What is the benefit? I have not mentioned here these numbers, but they calculate this. What is the difference in the treatment cost with new package with earlier? There is the extra. Also this inoculation cost, but some other improvement area, nodule count and reduce the shrinkage defect. So that is the plus side. Also reduce the development type and cost. That is also plus side. Machining effect also. So altogether, they found is around for particular on component, it is around 4 lakhs per annum is the saving. So from there they decide go for the full package to all the component where they are facing challenges. So when we are working with foundries, myself as our technical team member, myself and my colleague Balaguru and Shubinay also, we are visiting various foundries and always try to do this thermal analysis, check the current condition, then we recommend. So this which combination will be the best choice for them. And till the last stage, we do this all this calculation and present to the customer the cost benefit analysis. So in this is the thermal analysis graph. When you go through this, then it will give the idea. The micro shrinkage and porosity, mostly this process related is the carbon equivalent, silicon level, residual magnesium is most important, and holding time. In case of shrinkage porosity, then phosphorus, niobium, vanadium, and time. So this element most of the cases found if people they overlook. They all mostly check this, what is the residual magnesium, carbon equivalent, silicon and some other element. But this is most important to control the microporosity. So from all this case study, there is summary I have demonstrate here. Lanthanum containing ferrosilicon magnesium is having more beneficial to control on the micro shrinkage. Preconditioner is contain aluminum zircon base, always beneficial, and most of the found is who already use and they are going with that direction. Also, for the reduction of shrinkage, your nodulity and nodule count is most important. So you have to select parameter and alloy package which can give this high nodulity and nodule count. It is beneficial to control the micro shrinkage. So in conclusion, preconditioner for ductile iron is important to improve the nucleation potential. Is same for the gray iron also. Enhancement of nodule count. It will help to get this more ferrite content and control the micro shrinkage. This is the benefit. So nodule count increase is lot of benefit. Also, it will help to improve the machinability. More graphite precipitation, either is flake and nodules, it will give this better machinability. So you have to select this combination that helps to precipitate more graphite, either flake or nodules. So this is for the ductile iron with high performing package combination that helps to improve the yield. So next topics will be the core wire treatment. So in any magnesium treatment, normally when we are doing this ferrosilicon magnesium treatment, there is a two effect is going on. This magnesium, this is the for the sandwich process. Magnesium, even core wire, magnesium will react with this sulfur, also react with this oxygen. So two effect on is the desulfurization, another is the deoxidation. So after this magnesium treatment, there is a lot of MgO, magnesium oxide, sulfide, and magnesium silicon particles. Some will be the bigger in size, and that will goes to the slag. And there will be some is this very smaller. It will create this nucleation site. So when you are going for this ferrosilicon magnesium as a treatment alloy, so there is a lot of reactant product, the magnesium sulfide, calcium sulfide, rare earth containing. But when you are going for this pure magnesium, only magnesium is there. There is a two ingredient, only magnesium oxide and sulfide. So from here you can imagine what is the level of nucleation after magnesium treatment. In the both cases, with pure magnesium treatment, and another is the ferrosilicon magnesium through sandwich process. There is a huge difference on the metal quality. You will get this after magnesium treatment. So then you can imagine what will be your effect on the final castings. With pure magnesium, there's recovery on the lower side. In case of sandwich, you can get this even up to 80% magnesium recovery. So you have to calculate what is the benefit recovery part, and also nucleation that is improving the metal health. This is a different ferrosilicon magnesium treatment process. In this picture is demonstrate when you are going for this high magnesium content alloy, there will be the violent reaction, huge fumes and slag formation. very low inoculation effect. So all are the negative side. On side is positive, mostly is the your consumption will be the lower than sandwich process, no doubt. But when you are going to produce very critical and very stringent component for automobile, so your structure should be very good. So when your nucleation effect is less, low, and more slag formation and more fumes, definite in the final casting you will face there's lot of metallurgical challenges. So that I'll show in this few case study where we have seen earlier with cold wire, and then later on same foundry they switch over to sandwich process. Initial, yes, there will be the rosy picture that consumption is the less as compared to sandwich, and everybody thinks there will be the cost benefit. Maybe initial you will find this benefit, but in long term you will start facing these challenges, and there will be the huge metallurgical issue. So in India, most of the cases for this is why they have shipped. This is our findings. Maybe other company will think in a different way. This is our strong belief. It is a low cost and reliable automation, and also helping to reduce manpower and handling. Also during treatment inside this foundry, fumes not visible, but it will come into atmosphere through exhaust, and potential addition is cost reduction. That is the thinking. Most of the cases, what is our study and observation? When there is a layout little bit on the constant and small foundry, even they don't have dedicated technical manpower, so they are mostly thinking to shift from existing sandwich to cold wire. Challenge, there will be the metallurgical related, and no automation or feeder solution is there, and they are doing this small B and C, that is the small industries who are thinking for going this route, cold wire treatment, due to their some their in-house issue related. And cold wire is the blend of ferrosilicon magnesium powder with magnesium, pure magnesium. This is a combination. Typical composition around magnesium 25% with calcium plus rare earth content. And addition rate, whatever we have observed, it is around 0.4 to 0.5%. Definitely it is lower than sandwich process. Also, there is some demand from OEM go with this automation. So foundry people, they are thinking to change over from the sandwich to cold wire because there will be some automation. So this is the on-site push. But challenge for in this case is this power cost, technology, gap skill workforce, and also raw material related. This is the challenge for everybody's, either sandwich or cold wire related. When somebody is recommending cold wire, they are claiming that advantage with this addition rate will be less and more accurate on the quantity. And on the ESS environment point of view, there will be no fumes inside the floor. And there will be the less error on the weighing, that how much quantity, it will be the accurate quantity. This is the claiming on the advantage. But there is also inconsistency on code or homogeneity or whatever they are mixing or blending. If it is not homogeneous, then there will be the variation on ladle to ladle. This is the most problematic area. Or also, whatever this wire they are using, chances of breaking during feeding. So that is also quality related concern. So in cost impact, if you calculate with this process, there will be immediately, suppose when there is the coder, whatever we have observed, customer, they are changing their getting systems. They increase the riser runner to compensate the micro shrinkage. So that means they are compensating on the yield, casting yield. So if you calculate how much I'm gaining with this magnesium treatment and how much losing on the yield when you are increasing the riser runner's size, then you will get the real picture is really beneficial or not. This is the most of the cases very rare they calculate, but when they start facing these metallurgical challenges, then try to start activities. Where is the wrong? And in this case also, treatment is on the higher side, treatment temperature. And magnesium recovery already I have mentioned, it is on the lower side, around 30 to 40% as compared to sandwich process. There is, you can achieve up to 80%. So against this, all this advantage and disadvantage, there is some case study. This is the on foundry. They initially they are with the sandwich process, then they change over to coder, considering there is the cost saving. So they found they started that porosity and field failure. It is field failure from when the casting already fitted in the vehicle, so there is the failure. So they are using around 22% contained ferrosilicon magnesium with cerium plus lanthanum in the mixture of code wire. And charge mix, scrap as an 40% return to 40% boring. There is no figure. Magnesium is a calcium barium base they are using, and code wire treatment. So when our team, especially this Balaguru and other team member visited, and they done this thermal analysis with the existing combination and with new combination, this ferrosilicon sandwich process with lanthanum based ferrosilicon magnesium. In this picture, you will get the idea. Normally, in case of edge iron, in final G3, that is the green portion, it is the last graphite precipitation. If it is on the higher side, then you will get the more nodule count and effect will be almost negligible. So when they are producing casting through code wire, there is a G3 around 60 to 65%. So the same metal, they switch over to this ferrosilicon magnesium sandwich process. You can see G3 is around 81%. So this is the huge difference. And inoculant also they change over from calcium barium. Initially it has the calcium, both cases the same, only this changes in the ferrosilicon magnesium. That is the huge improvement on the LET that is indication of metanucleation level. And also G3 and ST angle. ST angle is the last stage that so that gives the indication of the shrinkage tendency of the castings. So when your G3 level will increase and LET level will increase, definitely there will be the lower on the ST angle. But here with when they are putting this casting through cold wire treatment, angle also on the higher side and G3 also lower side. So this is the changes, and later on this found they switch over from cold wire to sandwich because of these the metallurgical challenges. There is one more study. There is a lot of study, but here this time constant I'll go through only two. This is also shrinkage and leakage. They found this in this pressure test. So this is the structure. When they are using coda treatment, scrap addition around 70% and 30% return. And they are in ladle, they are using around 0.6% calcium barium, and coda addition is around 0.5. MSI inoculant, they are using 0.1% cerium base inoculant. This is the structure. And when they done this thermal analysis, in two cases, this left side, it is with the new combination is lanthanum base ferrosilicate magnesium with cerium base inoculant. Both cases, you can see these changes of nodularity and nodule count. So most of the cases, whatever our finding with different foundries who started cold wire, this type of structure, they are getting more or less, not everybody, but most of the cases when this process and raw material selection, inoculant selection is not the right way, this type of structure they are getting. In cold treatment, overall treatment cost on the loss side, but there is the high rejection level. This is our findings. Higher tapping temperature, that is also another additional cost. And also yield, casting yield especially, that is on the lower side, because they have to increase little bit on the ingot systems for compensate or neutralize the shrinkage related defect. And our thinking, it is not completely eco-friendly. Anyhow, there is the huge smoke, not the inside, but outside the plant. And higher pure magnesium consumption, and more or less is the more magnesium lost as a, because when there is the recovery is less, that means it is remaining, it is going in the slag and creating a lot of fume also. So in short summary for the cold wire treatment related, there is a defect in the shrinkage and dross and carbide. This is the most cases we observe. Carbide also. And there is the lower side on the casting yield. And impact, this is because of this increasing in the riser runner thickness size, there is the loss in the overall casting yield. And metallurgical point of view, there is the not consistency. Always there will be variable heat to heat, and your magnesium recovery on the lower side. This is the overall summary on the cold wire treatment. But in general, this most of the cases, sandwich is the best method on the metallurgical point of view. So you have to decide which will be the better choice considering your casting profile and which metallurgical requirement. Suppose customer requirement point of view, then you have to decide you are going for the sandwich or powder. But always our suggestion to the customers, go with the sandwich process. That is the best method, and considering the metallurgical parameter. Other pure magnesium not up to the mark on the metallurgical point of view. So this is from my side. So maybe we can go for this question session, or hello? 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 Hello?
You are audible, please continue.
Yeah, I have finished my presentations. So maybe we can go for this question answer. Hello? I think so.
Requesting the members, just in case if there are any questions, please unmute themselves and you can ask the question. Thank you.
There's one question in the chat box I can see.
Biswas sir, you can just check the chat box. The question is posted in the chat box.
That is 500 by 7 grade with 40% perlite. Correct? In my chat box, I am able to see this one question. Hello?
I guess sir, they do not have the mic access. So maybe they'll be posting it on the chat only.
Yeah, there is one question 500 by 7 grade. So that gentleman is there. Can I
Yes, sir. He is replying in the chat. You just say your answer. He will be replying to you in the chat.
see main that's 40% perlite in 500 by 7 grade. It is almost we can say 60-40 or sometimes maybe 50% also. So what is the main issue? Are you getting more ferrite? So then see in 500 by 7, if it is more ferrite, then better to check your chemistry, because if it is minimum 40% perlite, I'll reply through chat. That will be better.
Sir. Hello. Hello, sir.
Hello.
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 Sir. One question. So one question, sir.
Yes.
Sir, can you brief explain between the nucleation difference between core wire treatment versus sandwich, sir?
Then I'll share this present PPT again. Then you will get a better idea. Just 1 minute. Are you able to see my slide?
Yes, yes, sir.
So in pure magnesium treatment, when you are going for this pure magnesium treatment, that is magnesium metal, you are getting magnesium sulfide and oxide. There are other, you can see impurities or nucleation, it is less. But in case of ferrosilicon magnesium treatment, below, then you are getting this, all this ingredient. Sulfide, oxide, MgSiO3. So that is not getting from this pure magnesium treatment. And also another things in pure magnesium treatment is very violent reaction, huge, tremendous. And during that times, system is losing more oxygen from due to this violent reaction. But in case of sandwich process, that reaction is not so violent. So because of this ingredient, because in pure magnesium, only magnesium is there, but in other cases, calcium, rare earth, all the combination. So that's why it is giving this different nucleation site. And when nucleation site on the very much lower side for due to this pure magnesium treatment, you have to go with a higher inoculant addition rate. Also, you have to use this very high performing inoculant. So then some extent you can improve your nucleation site. So this is the difference between pure magnesium and sandwich process. So because of the lot of ingredient after magnesium reaction is coming from sandwich process, so always most of the, you can say I think more than 95% found people globally, they are in the sandwich process, very limited in the cold wire process. Only one side, if you think for the less magnesium addition, then I think maybe it will give the wrong picture overall on the cost point of view. Okay.
So we have another question in the chat from Surendra Vishwakarma, that how to increase nodule count in microstructure.
Okay, so I should reply in the.
Sir,
See,
it's
nodal
okay. You can just message, call in team meeting also. You can say it would be
Okay.
better.
See, nodal count in our observation with various foundries, the cerium containing inoculant for ductile iron, especially, it gives high nodal count and nodularity as compared to any other type of inoculant. Because and another also cerium based inoculant promote more nucleation site, and it gives the graphite precipitation from starting to last stage of graphite precipitation. So when metal is almost near to this complete solidification, still that time also cerium based inoculant helps to precipitate graphite precipitation, and it create this more nucleation site. When there is a more nucleation site, you will get the more nodal count. So definite inoculant help to increase nodule count and nodularity. But along with that, also you have to think about what is your metal, base metal condition. If it is nucleation site on the lower side, then need to correct the metal nucleation site, maybe either adding the silicon carbide or maybe a strong preconditioner. I already explained this is zircon aluminum content. It will help to increase the nucleation site in the furnace. After that, if you go with this cerium containing inoculant, it will help further to increase the nodule count. In most of the cases, you have seen the changes of structure when foundries is switch over from this normal standard calcium barium base inoculant to cerium base, then there is a huge increase on the nodule count and nodularity. I am not telling that calcium barium is not the good inoculant. Definite, it is helping. Majority is using calcium barium, but when there is a specific requirement, you need to increase the more nodule count. You are looking for the more ferrite content, or you are looking for to eliminate micro shrinkage, then nodule count increase is the most important. So in that case, barium containing inoculant, it not up to the mark. It will not give us, it will not help to increase that level of nodule count and nodularity. So always better the cerium containing inoculant. Next.
I guess there's another question from Maxwell. In core wire treatment, does it come with inbuilt inoculant or not? Is there any microstructure difference between inbuilt inoculant or only magnesium wire treatment?
Normally in coder, I have not seen that inbuilt inoculant along with this coder. Yeah, there is one found. I have seen, but separate. All cases is adding inoculant separately, but inoculant may be some companies supplying through code wire also, but no inbuilt. Even sandwich process, ferrosilicon magnesium, it will be not combined inbuilt with this inoculant. Inoculant definitely you have to add separately, either code wire or sandwich process. Inbuilt, I don't think is anybody supplying. It is separate. And another thing, suppose in case of sandwich process, if you add ferrosilicon magnesium and then inoculant together, you will get the less inoculation effect, because during this violent reaction, there is a lot of nuclear site will destroy. So always better to add inoculant separately after magnesium treatment. This is then you will get the better effect. But due to this foundry layout, sometimes foundry people they add this inoculant in the treatment ladle itself. But in that case, always you will get the less effect of inoculation. You have to add little more.
We have
some in heavy section casting. See, when this casting thickness, in case of windmill, I have seen this maybe around more than 300 millimeter section thickness. So in that case, of the nodule count, maybe less than 100, 70 to 80 numbers. So in thick section, this long pouring time and solidification time, and during that times, most of the cases there will be fading effect, and nodules will coagulate each other, and due to this slow cooling and more cooling times, it will be bigger size. In case of thin section, you will get the very smaller size nodule, but in windmill or any thick section, always you will get the bigger size nodule. Count always will be lower side in case of thick and big size castings. Then any other.
We have another question from Jitendra. If part thickness is 120 millimeters, can we use cerium based inoculant?
120 millimeter thickness. See, before thinking for this inoculant, first you have to select this ferrosilicon magnesium. It should be the low rare earth containing ferrosilicon magnesium. That is the first action. Second action, if it is two-stage inoculation, then ladle with the calcium barium base, but at the last stage, MSI, it should be cerium base. Why cerium base? See, cerium base inoculant, each and every element, there is the positive and negative effect. Cerium is always increase the nodule count. This is the positive side. Negative side, it will explode and chunky tendency will increase. So, but that positive effect you have to take. So that's why in the last stage, a small addition, maybe 0.1% or less than that, cerium base inoculant. But in ladle, if you with the barium base, then it will help. But ferrosilicon magnesium should be low rare earth content within maybe 0.4, 0.6 in between. So then overall yours cerium content will be on the lower side, but you will not get any metallurgical related defect. So this action in both sides, ferrosilicon magnesium plus inoculation. So 100% cerium based inoculant for 120 millimeter thickness will be not right selection. For 20 millimeter section thickness in definite, my suggestion will be the cerium base because that gives the best structure and metallurgical properties. Barium base also you can use, but my experience, considering my experience, I always recommend go with this cerium base inoculant. It will be lesser. See, you have to calculate in that way. Say always barium base maybe 0.4. If you go for the cerium base, maybe 0.25 to 0.3%. So quantity will be less. If it is both are the same, I think there will be something wrong. Cerium base is the more powerful inoculant. Quantity will be on the lower side than any barium calcium base inoculant. So this way you have to calculate the cost part. For 120 millimeter thickness, we not recommend go with this lanthanum base ferrosilicon magnesium. Always up to 70-80 millimeter lanthanum base is better, but on the higher thickness, lanthanum sometimes gives problems. So better is rare earth content, but less rare earth. It's around 0.4 to 0.6. That will better. Is there any other question?
Yeah, I guess there's one question from Logesh. How to avoid the shrinkage in the neck regions of the casting?
See this normally shrinkage in the gating area are opposite to ingate. So this is the normal phenomena of most of the cases. So in that case, uh, see, normally any metallurgical, if it is the metallurgical, you have to find out if each and every castings you are getting the same location defect. So then you have to focus on your methoding part. If it is not, or maybe few casting and sometimes we are getting, that means you are metallurgical related. So you have to take care on the metallurgical. With combination of inoculant and ferrosilicon magnesium, definite you can eliminate shrinkage at the neck area along with this chemistry. That means carbon silicon, that part also you have to adjust. And phosphorus definite for ductile iron, it should be as low as possible. So this combination maybe definite you can eliminate micro shrinkage. Later on, if you can send this more details through the email or maybe WhatsApp, then I can give you more information, because for suggesting any combination need to know your existing condition. What is the chemistry part? Which type of microstructure you are getting, and which combination of magnesium inoculant are using. Then it will be better to suggest correct combination. Otherwise, really is difficult. But cerium based inoculant, it helps to control this shrinkage. That is the no doubt about. You can think for this cerium based inoculant. Next.
Yeah, I guess the last question is for 120 millimeter thickness, can we use lanthanum based ferrosilicon magnesium?
Yeah, I explained that for the 120 millimeter section thickness, always better to avoid lanthanum based ferrosilicon magnesium, because in our experience with various foundries, up to 70 to 80 millimeter thickness, lanthanum base is okay, but after that there is some problems faces. So better to go with this cerium containing ferrosilicon magnesium, means rare earth contain ferrosilicon magnesium. But in rare earth should be on the lower side, maybe 0.4 to 0.6 level rare earth will be better.
Okay, so I guess we can request you to maybe post your mobile number or email ID in the chat box, so that if any of the members would like to contact for further questions, they can get in touch with you.
Yeah, that will be better. I am posting my email address.
So members, you can just contact sir as per their contact information for any further questions. So now we'll be moving on ahead with the event. Thank you so much, sir. It was a very insightful session. I'm sure all the members would have gained a lot of knowledge as per with your 27 years of experience you have poured into your presentation. It was very beneficial for everyone. So now moving ahead, I would like to request Ms. Mansi Bhatt to please give the vote of thanks.
Thank you so much, sir. A very good afternoon, everyone. On behalf of the Institute of Indian Foundrymen, Nagpur and Chennai chapters, I, Mansi Bhatt, extend our sincere gratitude to our esteemed guest speaker, Mr. Swapan Kumar Biswas, Technical Manager at Elkem South Asia Pvt Limited, for delivering such an insightful and informative session. Your expertise and practical insights have been truly valuable for all of us today. We also express our heartfelt thanks to Chennai Chapter team, Mr. Senthil Kumar, Chairman, Chennai Chapter, Mr. Raj Mohan, Honorable Secretary, and all other office bearers team for their guidance and support in organizing this webinar under the Big Brother project. Also, I would like to thank Nagpur chapter team, Mr. Nikhil Sharma, Chairman Nagpur chapter, and Mr. Irfan Makki, Vice Chairman, for their efforts and coordination in making this session a success. I would also like to thank all the participants and team for their active involvement and keen interest, as well as organizing and technical team for ensuring the smooth conduct of this webinar. Once again, thank you all for your presence and valuable contributions. Have a wonderful day ahead.
Okay, sir, we would like to
Okay.
conclude the meeting now. Thank you so much,
Okay,
everyone.
thank you.
Thank you. Bye-bye.
To all. Bye.
Thank you.
Thank you, sir.